Yeah, hello guys. So let's revise the last session's topics. So in the last sessions, we have discussed some of the classes like order by and group by having. So we have we have saw that this with an examples. Order by is it is basically used to sort out the results in a two ways. One is ascending order and another one is descending order. And the group by class, it is used to group identical rows into a single row. So under having, so this class is used to filter the results in a group classes. So and we have discussed data constraints like primary key, a unique key, a not null, a check constraints along with an examples. But in the last sessions, we haven't discussed about foreign key. So from today onwards, we are going to start with this one. So actually foreign key. So actually foreign key is any constraints. So it is used to make relationship between two tables. So here the relationship is nothing but a connection. So it is used to connect between two tables. So that refers the primary key in one table. And the table with the foreign key is called the child table. The another one table, which one is having primary key, is called parent table or reference. So basically the foreign key, so it is used to make relationship between the two tables. For example, let's consider we have a two tables. One is a department table and another one is employee table. So in the each and every department has employees. So we can store, excuse me guys. Yeah, wherein let's consider we have a two tables like a department and employee. So in the department table, we can store the department details like department ID and which department it is like let's consider HR department or else TR department, financial, etc. But whereas in employee, we can store the employee details. So whenever we want to retrieve data from among those details, among those tables, in that cases, we can use foreign key. So by making relationship between two tables, we can get the results occurrency.
Excuse me, sir.
Yeah.
Sir, may I know how many topics covered? Because it is the first session for us.
Oh, okay, okay. So actually, I forgot to say one thing. So some of the members are new to these sessions. Is it, am I correct?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Okay. So, sorry. Uh, Mohammed, can you please mute? Yeah, don't worry, guys. So we have covered basics topics. So you can find the recording sessions in the YouTube channels. So go through that videos. So if you have any queries, you can note down all those queries, and we can make a separate classes to discuss to solve those issues. Okay, guys.
Okay, sir.
Okay, sir. Got it.
Yeah. Okay. Thank you. So the basic syntax. So the syntax for making a relationship between two tables by using foreign key. So we can add foreign key to a table in two ways. One is by using the alter command. The another one is whenever at the time of creating table, we can directly add the foreign key. So this is the syntax. So we need to use the alter table under here the child table is nothing but on which table we are going to give the foreign key. So that is the child table, and we need to use this constraint add foreign key, and on which column. Here we need to specify the column name on which column the foreign key should be added, and we need to refer. This is the reference. So refer here we need to refer the parent table. So parent table name. So in the parenthesis we need to mention the parent table column which is containing primary key. So primary key. So here the child table is the table where you want to add the foreign key, and for FK column is the field. And this is the explanation about that. So now we are going to see with an example. So those who are new to us, here we have created database that is called PCS database. In this database, we have created a lot of tables, which are covered in previous sessions. You can find that. So we need to use whenever we are going to deal with table, we need to use database first. Use our database name is PCS. So let's suppose. So in order to use foreign key, we need to create two tables. Then only we can make relationship between those tables. So now I am going to create two tables. One is department and another one is employee tables. For creating table, we need to follow some structures that create table, and the table name is department. Or means here the every department has a unique ID. So for that, I'm going to define a one department ID. So department ID. So it is integer type value. So we need to add primary key. So then department name. So it is a varchar type. I am going to give the size as 20. So I'm going to create another table, that is employee. Create table employee. So in the employee, every employee has a unique ID. So emp/id is into data type primary key, and the another one is name. So varchar type. And so here we need to give the primary key. Here we need to give the foreign key column. So that is nothing but to department ID. Because here we are going to make a relationship between two tables. So in both the tables, the department ID should be matched. Then only we can make the relationship. Otherwise, we cannot make the relationship. So it is nothing but integer data type. So now I am going to the make relationship between two tables using foreign key. So the syntax for foreign key is, as we saw here, is okay. So I am going to add the foreign key at this time. Foreign key, and we need to mention the column name, that is department ID. So we need to refer this column, foreign key column, to a parent table. So for that, we need to use keyword reference. That parent table name is nothing but department. So departments. So in the departments, we have a primary key. So that we need to mention here. So that primary key column name is department ID. So I'm going to run the all the multiple statements at a time. So for that we have to use this icon. Employee already exists. Oh, sorry guys. So in my database, the employees already exist. So I'm going to change employee PCS. So now the two tables has been created, and the relationship also has been created. So now I'm going to insert some records in both tables. For inserting, insert into departments values. So that primary key value is 1. The department name is HR. Let's consider. The another one is 2, and the another one is IT department. The third one is finance. So the record has been inserted in a department table. So we can check by using select statement departments and execute. We can find the records. So in the same way, I'm going to insert the some fields in employee PCS table. So insert into employee PCS values. What are the fields? So employee ID. So I'm going to give employee ID as a 101, and employee name is Rohit. And here we need to give the foreign key value. So that is 102. Ganesh 2. not 3, and then the name would be like Mahesh. And the ID is 1. So here there is a catch. So we as I said, the relationship has been successfully made between two tables, employee PCS and the another one is department. So if you whenever you try to insert values in employee PCS using these fields, so if this value, that means so department ID, so the value, the department the department ID value in the employee PCS should match with department department ID column in the departments tables. Then only it will execute, otherwise it will throw an error. So for example, if you try to insert, successfully record has been inserted in employee PCS table. So whenever you try to insert like 104 and Muni, and the value should be 99. Let's consider. See, if you try to insert by using mismatch values, it will throw an error. So the error like cannot add or update child row. So because here the department ID in PCS employee PCS table should match with department ID in department tables. Then only it will execute, otherwise it won't. It doesn't allow. So now we have successfully inserted records in both tables. And the row one is by PCS. Okay. Let's so this is our department and this is our employee table. So now I want to fetch records from our department tables. So those who are having department name like HR. Select department name from departments. So it will all departments. But if you want to certain, then we need to use where condition where department name HR. It will give only HR. So now we have retrieved data from department tables. So as well as we can retrieve the data from employee PCS tables. I want to see name, EMP name from employee PCS, where EMP ID is equal to 101. So if you run this, it will give the record on basis of the condition. So just now we have seen we retrieved the data from department tables and as well as employee PCS tables. So but my requirement is I need to retrieve records from both table at a times, not a separate commands by using SQL commands. How we can achieve that? Here we can achieve this by using joins. So joins. So the SQL joins. So actually SQL joins are nothing but a class which are used to query and access or retrieve data from more than two tables. So it's based on a logical relationship between those tables. So just now I said, so I want to retrieve data from employee PCS table as well as a department at a both end. So in that case, we have to use joins, SQL joins. So in SQL, the joins are categorized in different types. So one is inner join, and the another one is self join and cross join and outer join. Here, the again outer join has differentiated in three types. One is left outer join, and the another one is right outer join, and the third one is full outer join. So inner join. So let's start from inner join. So basically inner join is a class in SQL. So it is used to retrieve the records which is matching in both tables. So this operation compares each row. So each row in the first table, it will compare in the each row in the second table. So and those rows will satisfied the data will retrieve. So if you want to work in inner join, we need to follow some certain rules. So basically in SQL, it is a default joins, whether you mentioned inner or not. So the SQL will automatically consider as a inner join. So on another point is it returns only the matching rows from the both tables. So that means whenever, so for example, if one table contain null value, it doesn't return. So that is the main rule. So if there is a no match, the record is an empty. See, it doesn't return anyone. So this is the symbolic format of inner join. So the table left side is a table A and the right side is a table B. So in the both table and the data will be retrieved based on the conditions. So that means the both table should match some conditions. So this is the syntax. So here the basis syntax for an SQL inner join is always we need to follow the select statement. So select. So here we are using join. So that means we need to use two table columns, more than two tables. So the table one column name, table one column two, column three, and so on, and as well as table two, column one, column two. So from table one, here we need to mention the inner join. As I say, so whether you mentioned inner or not, the SQL will automatically treat that it is an inner join, and we need to mention the table name. So after that, we need to mention some conditions. So based on these conditions, this SQL statement will execute and finally it will return the results. So now we are going to see with an example. So for time being, I have already created two tables to deal with joins. The tables are Project. Yes. So for time being, I have created two tables and I made a relationship between these two bills. So one is employee table and another one is a project table. So in an organization, every employee has a definitely has projects. So in the employee table, I defined columns as employee ID, employee first name, last name, and his age, and email ID, phone number, and address. So in the project table, every project has a unique ID. In the same way, every employee in an organization has a unique ID. So that's why here the employee ID should be unique. And here also the project ID also should be unique and the employee ID. So as I said, if you want to make a relationship between two tables using foreign key, so in the both tables, the column should name same and the data type should also be same. Then only it will work. So here the employee ID is a type of integer type. In the employee table, employee ID, it is an also type of integer. And the every project as a client. So is a client name and the project name and which date and which year the project has been allocated. So this is the two tables. So now my requirement is so our requirement is so I need to display employee ID, employee first name, employee last name, and his project and a project name and on which year the project has been allocated. So select e dot emp id, e dot emp first name, e dot emp last name. And our next project is, yeah, project name. So p dot project name, e dot project start date. So from first table is our first table. So here, so this is the left side of table and table B is the right table. So in the same way, here our left table is employee as a E, and after that we need to mention join. So now currently we are dealing with inner join. So we have to mention like inner join. So and we need to mention that child table. This is nothing but a right side of the table. Our right side of table is project as a P. So now we need to give the one conditions. So on the basis of conditions, it will give the results. So on E dot employee ID is equal to P dot employee ID. So here our condition is, so in the both the tables, those employee IDs are matchings. So their names and their corresponding details are displaying like employee first name, employee last name, and project name, project last date. Sorry, project start date. So let's see. So let's consider. So in our employee table, we have a total 5 numbers, 5 employee IDs. So from 1 to 5. So in the project table, employee ID. So it will match. So it will match employee ID in the project table in employee ID in the in the it will match employee ID from the employee table to employee ID in the project tables. So after executing this command, our result will be like this. So employee ID and employee first name, last name, and his project name, and on which year the project has been allocated. So here we didn't find the employee ID 4. So because in the employee table, we have an employee ID of 4 and along with the details. But in a project table, we don't have a employee ID 4. So that's why we didn't get the employee ID 4 details. So this is the inner join. So as I said, if you forget to mention inner, the SQL will automatically consider it is an inner join. If you run this, it will be give the same result. See, the same result will be given like this. So here we found employee 3 IDs. So that means so here the employee ID in the project table. In the project table, we have a 2 employee IDs. So that's why the results are showing 2 times of 3. So because every employee, so every employee has a multiple projects. There is a no rule to that every employee should have only one projects. So every employee can contain multiple projects. So that's why we have here the result is like this. Employee ID 3 is having 2 projects. One is a project 3 and another one is a project 4. So there is the inner join. So let's deal with another one. Mm, or so for time being, I have written some questions. Yeah, right join. It is all not to consider the right join. Mm, okay. So can do that after some time. Let's forward to more. The another one is outer join. So the outer joins are 3 times left outer join and the right outer join, full outer join. So let's start from left outer join. So the SQL left outer join. So it combined rows from 2 or more tables on basis on related columns. So it is similar to inner join, but the minor change is whether see whether there is a no match, the result it will be given result as a null in the left join. But whereas in an inner join, it will give result as a empty. but in left join it will give result as a null. So the SQL left join combines rows from two or more tables based on a related column between them and returns all the rows from the left tables. So on the matched rows from the right tables. So whenever if you want to deal with the left join, so the left side of the table data will display whether the rows are matched or not. It doesn't matter. But in the right side of the data, it will give the results on the basis of conditions. But if there is a no match, in that case, it will give result as a null. So the same syntax like we followed in a join, same syntax, but here we need to mention left. So here, this one.
ఫస్ట్ అమౌంట్ మార్చుకుంటున్నా అడుగు అది 2000 వచ్చిందన్నా చూడు.
So what it is showing. So it is.
ఫోన్ ఉంది మొత్తం.
So it is giving results only the condition is satisfied. So if you perform statement using left join,
సరే యాడ్ చేయి అమౌంట్ మార్చుకుంటే
left. So in this case, so the left side table, so that is our left side table is employee. So in the left side of table, which is containing records, it will give all the records. But in the right side of the table, it will give the results on the basis of conditions. Those values are matching. But if the none of the values didn't match any value, in that case, it will give the result as a null. So if you try to insert, see in the previous example, we didn't find this one, fourth employee ID. So, but in the left join, we are getting these results. So the from the definition of left join, so left side of table, our left side table is nothing but employee. So here the employee details are retrieved perfectly. But whereas right side of table, our right side table is project. So it is giving the results on basis of the conditions which values matching. But here the fourth one is didn't match. So that's why it is returning result as a null. So by seeing the image of the left join, we can conclude that. So the left side of the table will give the left side of the table, which is containing the records, it will give. But the right side of the tables, it will give the only some certain values on basis of the conditions. Remaining values are it will throw as a null. This is the left join. So it is in the same way similar to a right join. It is opposite to a left join. So left side of the so the right table which is containing values, it will display all the values. But whereas in a left side, it will display those values which are matchings. Remaining values, it will display like null. So the same syntax we can follow for right join also. So just we need to change left to right. So take the same example. So we have C. So in our previous example, we have dealt with the left side. So that's why it is retrieved all the records from the left side of the table. But if you try to use right join, we need to use the right keyword. So if we execute, it will display the same results, but the minor change is it will, sorry guys, it will give the null values. See, so so in our project, we have an employee ID 1, 2, 3, 3, 5. So these employee IDs are matching with from employee ID in the employee table 1, 2, 3, 4, 5. So what is the 4, 5? So that's why it is showing the accurate results. But if you notice, we have a more than 5 employee IDs, 9, and the another one is 7, 8, 7. So these employee IDs are not matching with this employee ID in the employee tables. So that's why it is showing a result as a null. But the right side, if you notice the right side of the table, our right side table is project. So the employee IDs, which is contain 9, 7 is, so these values, project name and project start date, are retrieved successfully. But the left side is didn't match it. So that's why it is showing as a result null. So this is the, it is looking like similar. And this is the diagram of the right join. And the another one is a full outer join. So actually, full outer join in SQL is a method to combine. So just now in previous we have discussed left outer join and right outer join in separate way. So what if we want to perform at both outer joins at a time? So in this case, we need to follow full outer join class. So it combined rows from two or more tables and based on a related column between them. See, so actually the full outer join will return all rows from the left table as well as a right table also. So the full outer, so this keyword, this is a keyword. So this keyword combines the result of both left and right outer joins and return all matched and unmatched rows from the tables on the both sides. This is the keyword we need to follow. But in so currently we are using MySQL. So MySQL doesn't support to full outer join, but we can achieve the full outer join by using um, one constraints, that is nothing but unique. So if you see, is this different syntax? So whenever we are going to deal with the full outer join, we need to mention both table name, left and right. So this is the left side of the table. So from employee ID, from employee table, we are getting employee ID and employee name, first and last name, and project ID and project name from employee. Table. So this is the left side of the table. So that's why we're using the left join. And the right side of the table name is a project. On which conditions, on which basis we are going to perform this SQL commands. So that condition should be here. So we are comparing employee ID on both tables. So that's why from employee table to from project. And then we need to use the union. So union. So by seeing this name, we can think union. It is so it group all the things. It combines. On the select, it is a similar to a left. So the same syntax we need to follow. But the minor catch is we need to change from left to right. So from left to right means here also we need to change our table name. So in the left side, so we have to mention left table, that is so employee. So here we are using right. So that's why we need to mention first right side of the table. So on then only we need to mention left side of the table. And in the same way, we need to mention the conditions. So from employee table, we are comparing the employee ID with the project that is containing the employee ID. So if you run this command, so by seeing this results, we can conclude. So the full outer join. So on the basis of the definition, see, so it returns all rows from the left table and from the right tables, whether the condition is matched or not. So that's why it is retaining all the values. So whether it is matched, so these values are matched, and the fourth one is didn't match. So that is the full outer join. So basically, in most in the industries, we didn't deal that much by using this full outer join. So most of the cases we are going to deal with the joins, inner join. Inner join is are using frequently, widely compared with the outer join. On the another one is self join. So it is in one kind of join in SQL. So the self join is a standard SQL operation where table is joined itself. So as of now, we have dealt with the two tables. So but if you want to perform in the table itself, in this case we need to use self join. So actually this can be useful when working with the hierarchical data, like or when you need to compare rows within the same table. For example, let's consider I have one table, like the table name is employee. So the table contain fields like employee ID and employee name and manager ID. So every employee has a manager. So in this case, we can compare our table itself. Like we can compare rows within a table itself. We can find the manager of each employee. In this case, we can use the self join.
Like the row.
So this is the syntax. Select column. So this is the we can achieve in a different ways. So this is the one of the way in SQL. So as I said, joins. So whenever we are dealing with the joins, always keep in mind we need to make relationship between two tables or within the tables, and as well as we have to use two keys. One is primary key and another one is a foreign key in order to make relationship. So for time being, I'm going to demonstrate you with an example. Uh, let's consider table name. Create table employees. Let me check my database. Contain no, there is a no employees. Okay, fine. So our employees table contain emp id. So the id should always integer, and the id should always contain primary key because every employee has a unique id. So primary key and employee name varchar 20. So here I am going to define one more field, that is nothing but manager ID. So the ID is nothing but int. So why I have defined manager ID here is, so each and every employee, so we can create a separate table for manager purpose also. But in order to deal with the SelfJoin, I have created manager ID within this same table. So as I said, we need to make a relationship with no, within itself. So for that, we need to use foreign key. Foreign key. So our foreign key would be manager ID. So we need to refer parent table. Reference our parent table is employee itself. Here we are referring employee table itself. Employees. Then we need to give our primary key column name. Our primary key column name is PMP ID. So that's it. So the table has been created successfully. So we can check the description of employees. So see, the same table, we are having primary key and multi-type value. That is nothing but foreign key. We can define foreign key, unique key. We can define multiple constraints on the same column. So that is why it is showing multi-type. Now I'm going to insert some records into this table. So insert into employees values. So one Rohit, I'm going to define null. And the next one is 2. Muni. And I'm going to assign manager ID as a 1. So in the same way, I'm going to define 3 fields. Ishwar 1. So another one is 4. Babu 2. On the final, I'm going to define one more field. Yeah. Okay. Ayu Charan and 2. See, the record has been inserted into this table, so can get this result. Employees. Yeah, this one. So now we are going to discuss self-join. So let's suppose I want to retrieve names of employees along with the names of their manager. For example, I need a employee name. So for example, this employee name having employee ID. So I need to find who is the manager for this guy. So we can compare by employee ID. Select e dot empid empid as employee ID and e dot emp name as employee name and m dot emp name as manager name. So from our table name is employees. Employees as E. So here we need to use one join concept, that is left join. So the reason behind is so for example, let's all employees are included, whether the employee has a manager or not, it doesn't matter. But we need to display the employee name. So that's why I am using left join. So left join and our employee tables. In this case, we need to define as a M. M is manager. After that, we need to make one conditions. Like we need to compare. So E dot RTE, yeah. M dot manager ID. To EO. It's and M dot EMP ID. So let's run all the comments. So here we are performing self-join with the same table like employees. So in the employee table, we are having employee ID, employee name, and manager ID. So our requirement is find employee name and along with the manager name also. So our condition is based on the IDs. So our employee ID is employee MP ID is this one 1, 2, 3, 4, 5. And our manager ID is in the manager ID, some fields contain null, some fields are having values, one more or none. So this condition will compare. So this employee ID will compare this manager ID. So line by line, it will compare. Whenever it encounter the match is successful, it will assign the corresponding values. For example, first here the employee is taken, so it will check within itself the table itself. So here employee ID, so here our manager ID. So first take manager ID and we are comparing employee ID. So here we didn't find any manager ID. So then it come up with the next row. So here we find that our match is perfect. So then this corresponding EMP name, that is Muni. So this Muni is a now this Muni will act as a manager to employee name, that is Rohit. For Rohit, Muni is an manager. So in the same way, Rohit as a another manager like Ishwar. Like this way, here it is defining. Mm, Charan, Charan, this one. So we're dealing with the two numbers. So we are comparing deal. So Muni is a manager. So Charan is having Muni as a now act as a manager. So this is the self join. For example, the final one is cross join. So cross, by seeing this name, we can conclude that so it will compare, not compare, it will match every row from the left table to right tables. So the cross join in SQL is used to combine every row of the first table with every row of the second table. That means left table to right table. So this cross join is also known as a Cartesian product of two tables. So Cartesian products are nothing but we can say in mathematics multiplications. So here in simply we can find, so here let's assume that we have in three records. So multiply with 3, we can find a 9. So the total outcome is 9. So the most important aspect of performing cross join is that it does not require any conditions. So in our previous topics, we need to make one conditions in order to perform joins. But in this case, we don't have to use any conditions. So the issue with the cross join is it returns the Cartesian product of two tables, which can result in large number. So as I said earlier, so for example, the table A contains 3 records. So in the same way, the table B contains 3 records. So it will multiply 3 times. For example, the 1 is compared with this left right side of the table where 1 as well as 2 and 3. So for 1 we have a 3 records as well as for 2 we have a 3 records and 3 we have a 3 records. So total 9 records we will find. So the output will be very large. So that is the issue with the cross join. So it has a criteria widely used when necessary. So we can use this cross join whenever we need. So the syntax is very similar to left and right join. So here we need to use the cross keyword. Instead of left and right, simply we can use cross join. For example, so in this table, not this table, we can take, yeah, this one. Let's suppose I can select this one. So the syntax we can see select column names. We can select multiple column names and from table, left side of the table, and we need to use the cross chain and we need to mention the right side of the table. So for example, I am going to cross join. So I'm going to perform cross join with the employee name. So select e.emp first name from employee e, and we need to mention cross join, and we need to mention the right side of the table. Our right side of table is project. Here I am performing cross join with the project table. Right. So if you run this command, our result will be like this. See, so we didn't find, so we can find the count. Count of employee. Let's see. EMP first name. No, we can't use it because we need to use the group by function. So let's see. Go GBay2. So this is the final result. So let's go delete this to one. Center. So we are performing cross join on employee first name column. So we are selecting the column name from the employee first name. The first one is a employee name. Let's consider Muni. So it will cross. That means it will pop as a name suggests Cartesian product. So product means is nothing but multiplication. You know how many times. So in the same way, so this employee first name Muni will compare with to this project. Sorry guys. So let's start from project. So this Muni employee will will perform the multiplication with this project table in every record. So for example, in this we have a 9. So we can find that we can find Muni. Here Muni is 1 and 2, 3, 4, 5, 6, 7, 8, 9. So it will give that much. So how many, it doesn't matter how many records in the right side of the tables. According to that, it will give the results in multiplication of that. So this is the cross join. So we can see this image. It is multiplied with each other, with each other in the both table.